This is section 2 of JEE 2020 paper 1. In this section, there are one or more than one correct options are there with negative marking, and here partial marks are also allotted. So let's go ahead for solving the question. Question number 7. And if you are first time on my channel, then please subscribe and hit the bell icon button to get the video first. In the question number 7, what is saying over here? So if you see, fx is x cube minus x square plus x minus 1 sin x. Here you can take out x minus 1 common at least. So better just you take out x minus 1 common over here. So here you will take x square common. Now x square plus sin x one can write, and hence if you see over here, then we see that f of 1 minus is equal to f of 1 plus, here what we called f of 1, that is 0. Okay, fine. Now as you know, that is fg into x equal to fx gx. So you see here in the option A, it is given that gx is continuous at x equal to 1. So gx is continuous at x equal to 1. It means what this shows? This shows that g is continuous. Let's we test one by one options. If g is continuous at x equal to 1, it shows that g of 1 plus is equal to g of 1 minus, means RHL equal to LHL equal to g of 1. And you know, g is arbitrary constant, arbitrary function. Okay, g is be an arbitrary function. Okay, means g, the definition of g is not given over here. So you have to consider the product of this function f into g as some new function, as like here we are assuming, you can assume f into g, you can assume any function, let's say hx, and if you say hx, then in case of limit h tends to 0, you write here, there will be confusion. So here we are assuming any say L be any function, right? So hx into fx equal to lx, say L say. Now, so for option A, what do you have to say? That L of 1 plus you have to solve first. So in the case of L of 1 plus, what do you say? What do you have to say? Limit means you have to check the differentiability, no? In the product of the function, differentiable whether it is at x equal to 1 or not. So you say limit h tends to 0, L means f into g now. So L of, what do you have to write? 1 plus h, as it is RHD, minus L of 1 upon h. And here what we recall, that limit h tends to 0, and you have to put f of 1 plus h into g of 1 plus h, right? And then minus, as L of 1, you know, it is a product. In case of f1 is 0, and so g1 will be, of course it will be, although it's arbitrary, but with the multiplication of 0, the result will be 0. So finally what we say, this upon h, and hence we say that it is nothing, it is f dash 1 into g1, f dash 1 into g of 1. Now you see here, what we call whether it is differentiable, as g1 is any constant, so it is arbitrary, it's some definite value, and here f dash 1 here, that is differential, means it exists some definite value. This shows that this exists, means fg is differentiable. So we recall that L dash of 1, as here what we say, this means this option is correct. Okay. But if you see here, fg is differentiable at x equal to 1, then g is continuous. They are saying that g is continuous at x equal to 1. It means this is given. Suppose this is given, and now from here, if it exists, then it is not sure that g of 1, so g1 is some existing value, definite value. But here we won't get that g1 is g1 plus or g1 minus. So it's a revert, may or may not be true. So this will be not to be considered. Now come to this point. If g is differentiable at x equal to 1, then fg is also differentiable at x equal to 1. So look here, as g is continuous over here, and here they are saying if g is differentiable. So if g is differentiable, in the case of continuous, if it is fg is differentiable, then of course indifferentiable also, that is fg is differentiable, right? So you can see like this way also, as you know, this one L function is there. So you say here for third option, what you have to say, L dash of x here, from here you can say, from here if you differentiate this, then you will find f dash into g, f dash x you can write, and gx plus fx into g dash of x. So what we say here, L dash of 1, L dash of 1 equal to f dash of 1 into g of, you say, 1, right? And here, as g1 is some constant, g is some due to this continuous, g1 will be some continuous function. So in that situation, this becomes vanished here. So this fx, this becomes, means you see over here g dash, and when you put substituting h1, then it will become 0. So you can say here, as, let me write, as f1 is 0, g dash x, here they are saying g dash x exists, g dash x exists, although it's at some finite value, but here what we say, fx will be 0, right? So you know, f1 is 0 now. Yes, from here you can see f1 is 0, f1 is 0. So when you are substituting x equal to 1, here you will get entire thing is 0. So L dash of, finally, what we conclude over here, that L dash of 1 is equal to f dash 1 into g1. This shows that if this one, g is differentiable at x equal to 1, if g is differentiable at x equal to 1, fine. So L of x is also differentiable. So L of x is also differentiable. Correct. It's okay. So finally, this one is also correct. C option is also correct if you see. Now check for D option. Once again, that's the same thing. If g is differentiable at x equal to 1, then g is differentiable at x equal to 1. So this will not be true, right? So only A and C options are correct. So here the answer will be A and C. That's the answer. Answer is A and C option. Fine. M be a 3 into 3 invertible matrix with real entries, and let I denote the 3 into 3 identity matrix. Here M inverse equal to adjoint of adjoint A. Better just take a mod both side. So M inverse mod is equal to adjoint of adjoint of m is there, and this is adjoint of m. Now take the mod both side here. So what we conclude that, as you know, adjoint of mod is um, that we say adjoint of adjoint A, that is mod m to the whole power. You have to write mod m. So mod m to the whole power, that is n minus 1 whole square. N minus 1 whole square. This is the formula where n is the order of the matrix. So here the order is 3 order matrix. So better just you can use 3 over here instead of n. So let me write 3 over here. So that is 3 minus 1. So 2 whole square, that is 4. You can say mod m is to the power 4. And here mod of m inverse. So finally, what we conclude that this is very clear that mod m is equal to I. Mod m is I. And this implies that adjoint of mod m here. Okay. So adjoint of mod m is also 1. Adjoint of mod m, that is, you can say 1. Fine. Adjoint of mod m is determinant of m, that is 1. So second B option is correct. Okay, fine. Now you say adjoint of m, right, and divided by mod m. What is the result? Adjoint of m divided by m mod m, that we say that is m inverse. Here m inverse we can write. So also we say adjoint of m. Okay, put it in bracket, adjoint, and here what we say that this result is adjoint of m. If you take mod over here, then what we say over here, that is means adjoint of m, that is whole square, and here what we say adjoint of m, okay, mod, and this is identity matrix. So what we conclude here, adjoint of m whole square is equal to, that is I. Okay, because adjoint of m is 1, substitute over here, you will get I. So D option is also correct. And from here also, we can say this one, m is equal to I. You can't say this. And what about C option? Yes, m square is equal to I. Fine. So mod m is equal to I. M mod m square. M square also, you can say here I. Identity matrix. Fine. C options are correct. So there are 3 options correct. Let's go for another question. Now this question is from complex number, question number 9. Let S be the set of complex numbers that satisfying this, then which of the following statement is true? So here you see, as from these options, this question seems like this shows that this is from triangular inequality. So apply it. And now let's start. Mod of z square, you just better make a perfect square here. For using perfect square, so z square plus z plus 1 mod can be written as this, you can say 1, this is given, and this can be written as mod of z plus 1 by 2 whole square. Making a perfect square, you have to add subtract like this 3 by 4. So this will become perfect square, and this can be shown as this. We see, you can say this is less or equal to mod of z is mod of z plus 1 by 2 whole square and plus 3 by 4 like this. Okay, so what this shows from here, it is showing that z is plus 1 by 2, z plus 1 by 2 whole square. You can write mod better, z plus 1 by 2 mod square. Yes, z plus 1 by 2. Better write like this, mod whole square. Separate it. And this is plus 3 by 4 when you transpose this one. So 3 by 4, 1 minus 1 by 4, that is, this part is, this is here, and greater or equal to 3 by 4 transpose is here. 1 minus 3 by 4, that is 1 by 4. Okay. And this implies that z plus 1 by 2 whole square, because this is asking here in A and C option, and here we can say z plus 1 by 2, that is whole square is not there, so take a square root and greater or equal to 1 by 2. So okay, here now you see z square plus 1 by 2, z plus 1 by 2 is greater than 1 by 2. This option is correct, C option. Now check for another, means among A and C only C is correct. B and D you can check over here. Here it is saying S has exactly 4 elements. So you see, later on we will think about this. And Z, mod Z is less than equal to 2. Means this is lower bound is there, and the upper bound you have to search out. So for upper bound, you just go like this way here. That is Z square plus 1. Also we can say. Also. That is 1 equal to Z square plus Z plus 1 mod, and that will be greater than or equal to, you can say, Z square minus of Z plus 1. Okay, so you separate by using triangular inequality here, and here you know this is this mod Z plus 1. Now you can see over here that it will, this will be greater than mod of Z or minus 1 mod. You separate this. So finally this will be also greater than that. So that we say greater equal to what we recall, mod Z square is there. Okay, you can write over here, that is a square, not like this, mod of Z whole square while separating, right? So mod of Z whole square, and that we say Z plus 1. Okay, so what we recall, mod of Z whole square minus mod Z, and here that is minus 1. Okay, that will be plus, after opening the sign minus, that will become minus. So this will minus. So finally what we conclude here, compare both with this one and transposing, this implies here mod of Z whole square minus mod of Z, and transpose this one. So what we say here, minus 2, and that will be less or equal to 0. When 1 comes here 2, and that is less or equal to 0. This implies that what we say, mod Z. Okay, so mod Z is less or equal to 2. Okay, so it seems somehow tough if you are not getting the idea of triangular inequality. This will be also correct. So here B and C both option are correct, and the set this one has exactly 4 elements. That is not correct. And now here tan x by 2 plus tan by z by 2 is equal to 2y upon x plus y plus z. Substitute the value as considering here as a by 2 and this as c by 2, capital A, capital B, capital C, and here you can say small a, small b, small c. So better just to go ahead like this way. So for tan, you can say think about a by 2, and we are using this formula. So that is tan, let me write over here, tan, you can say a by 2 and plus tan c by 2, and that is 2, that is y means that what we call b over here, 2, so 2b upon a plus b plus c. Okay, now for tan a by 2, what do you write? Under root of, that is s minus means b, that is sin a by 2 numerator, s minus b into s minus c upon that we say, and here the numerator of cos, that is s into s minus a. And now what the formula for tan c by 2, that is under root of that what we call s minus a into s minus b. Here this is numerator of sine, and numerator of cos is, that is s into s minus c, and that is equal to this part, that what we say, you can say 2b, and here you can write 2s, so we can write b upon s to related. And finally what we say here, now concluding this all, you can take out common over here, so that will be under root of s minus, that we say, for this root s minus b will be common, so s minus b upon, you can take out s also common, and here what left, you left over y, that is you say b, no, so that is you can write over here b. Confusion arises between a, b, c, so better just we write b over here, and here that is under root, now s is common, so s minus a and s minus c will be there, this part, and here that is b by s. So b we are considering as y, for b we are considering as y, for x we are considering as a, and for z we are considering as c. And here you just consider this capital A, capital B and capital C. And now as usual, what the formula you apply over here. So finally what we conclude, that we conclude over here and left with s into s minus, that is b, it means we are coming with y, and here that is s minus a into s minus c, and here that is 1, okay, because b related and s one is left in root s. And finally that is nothing, it is tan of, you can say, that is b by 2, that is 1. So tan b by 2 1 means we can say here tan of, that is y by 2 is equal to 1. Tan y by 2 is equal to 1. This shows that y by 2 is equal to pi by 4, and this shows, so y equal to pi by 4. So this implies here we can say y equal to y by 2 is pi by 4 here. So y equal to pi by 2 we can say, and hence as y equal to pi by 2, we can recall that the triangle is a right angle triangle. So let's draw the right angle triangle over here. Here let's draw one right angle triangle, and at this and at this. So as this is a right angle triangle, so we can think about as, let's say this is capital Y, this is say means here you can say x, here you can say z, right? So if it's a capital X, then there is small x. If it is this, then small y, and if this is z, this is small z. So finally what we get here, capital Y equal to x plus capital Z, as y is pi by 2 over here. So this option is B option correct. And now applying Pythagoras theorem, so we can say x square plus z square is equal to y square, here y square. So that what we say here, and also what do you say here, tan x by 2, tan, that is this part. So tan, for to check this one, tan x by 2 means this here, that is a, you can say this is a, this as b, and this as capital C. So tan x by 2, that is you can say under root 1 minus cos of, yes, you can apply formula, cos of x upon 1 plus cos of, that is x that is half argument formula we are using over here. So under root, what do you say, 1 minus z by y upon 1 minus 1 plus, you can say, z by y. And after solving this, you will get this one as, yes, you solve this part, then you will get y minus z upon y plus z, y cancel. So and dividing with this conjugate y minus z, here you get in denominator y plus z, and that is applying this one Pythagoras theorem, x square plus y square plus z square. Let me solve over here. So here what we get here, under root, after this you can see over here that you will get y square minus z square upon, that is y plus z whole square. And now here you can say, after solving, multiplying this one, so y plus y square minus z square, that you say x square, and here that it will be come to this one, that is x, and then after here that is y plus z free from root. So tan x by 2, that is y of x upon y plus z. So C option is also correct here. So the answers are B and C. This is question number 11 from three-dimensional geometry, and here there are two straight lines are given. So from here, if you see, what is the point of intersection, means from this, if you see in the numerators here of both the lines, then what do you find, that is the point of intersection, this point is common for both the lines. So here we can conclude that point of intersection. So let me write point of intersection section is that what we say of L1 and L2, of L1 and L2 is, that is 1, 0 and 1, that is common. 1 from here, 0 from here, 1 from here, 1 from here, 0 from here, 1 from here. So from these two lines, it is obvious that 1, 0, 1 is common. Now line L, this one, let suppose the straight line this passes through this point, and this line says plane containing L1 and L2 passes through the point of intersection of L1 and L2. If the line L bisects the acute angle between lines L1 and L2, then which of the following statement is true? This you have to search out. So so line L, consider any line L passing through this point 1, 0, 1. So let me write over here. Let line, any line L passes through 1, 0, 1, okay, is given by, that is means any point, you say, that is 1 minus alpha upon L, and here what we say, minus 1 upon M. These are the direction ratios, and here that is minus 2. So that what we say, 1 minus gamma upon, and that is here minus 2. Okay. So angle, acute angle bisector. Now acute angle bisector, you say, any acute angle bisector of L1 and L2. L1 and L2 is given by, in vector form, if you are interested to write, better write like this way, R equal to, that what we call R equal to I plus J, not J, that is I plus K, I plus K plus lambda times of, okay, so I plus K, because 0 is there, so I plus K plus lambda times of, I is minus J plus 3K, okay, I minus J plus 3K And then after this one, another line, that what we say, minus 3i minus j, and this is 1, so plus k upon that what we call here 9 plus 1, 10 plus 1, 11. So that is root 11. Fine. So this is R, acute angle bisector of L1 and L2. L1 and L2 line, this is R equal to I plus K. Okay. And lambda times of this. So this will be acute angle bisector, will be treated as R equal to I plus K, and plus you can say here T times of, in the equation mode we can write I plus J minus 2K, I plus J minus 2K. Okay. So the direction ratios are here, what we write, let me write over here, that is space not here, or better write here. So that is L upon 1 is equal to M upon 1, and here that is minus 2 upon, yes, minus 2. This shows that L equal to M equal to 1. And now from this one, equation number 1 you can say, and now from equation number 1 you can say over here, that is 1 minus alpha upon 1 is equal to minus 1. So this implies alpha is 2, and here 1 minus gamma upon minus 2 is equal to minus 1, and this implies gamma equal to minus 1. This is the final answer. So finally what we say, conclude that here you can now check the options. So as alpha and gamma, so on subtraction what do you get with alpha and gamma, that is 2 and minus 1. So this satisfied with this equation, this options, and another option, that is L and M. So element L and M, both of them are 1 and 1. So L plus M, that is 1 plus 1, 2. This option is also correct. This is wrong, so that's also wrong, and these two options are correct. So A and B options are correct. Fine. Let's go for another problem. So here in question number 12, there are the 4 options are there, sine, cos, and here x squares are there. Between 0 to 1 every limits. Inequality is there. So better just to go for expansions of sin x and cos x. So for every value of x belongs to, every value of x belongs to 0 to 1, one can write cos x cos x as, you write the expansion of cos x and then multiply with x. So 1 minus x square by factorial 2, x to the power 4 by factorial 4, and so on, dot dot dot, up to infinity. This shows that that is greater than x bracket 1 minus x square by 2. Okay. So if you are integrating this one, and here therefore we can say 0 to 1 for first option, that is x cos x dx. That integral will be also greater than this one, 0 to 1, that same x minus x cube upon 2 dx, and that the answer will be here, that is, and if you solve this, and you will find, and this implies, you will write like this way, 0 to 1 x cos x dx here is greater than, that we say 3 by 8. If you solve this, yes, it's okay. So first option is correct. Now similarly go for sin x also. So here 0 to 1 x sin x In sin x, you have to consider all the odd terms. So for sin x also, that is like this way. You say 0 to 1, that is x under bracket x minus x cube upon factorial 3. Factorial 3, that way you can say 6 later on. Factorial 3 here, right, properly. Factorial 3 here, that is, you can write here factorial 3 and dx, and hence this will be also, while after solving this, you will get this result also 3 by 10. So this implies here we can write 0 to 1 x sin x dx, that is greater than 3 by 10. Okay, so B option is also correct. Now come for C option. Similarly, if you go for C options, that 0 to 1 x square cos x dx, let me write like this, cos x dx, that is less than x square cos x, that is less than, it means 1 by 3. So what we say here, similarly you can go for like this way, yes, that is x square dx, and 0 to 1 when you are solving, then this implies that this will become here 1 by 3, so it's not to be correct. And here when you solve 0 to 1 x square sin x dx, that is greater than x square x minus x cube upon factorial 3 dx, then after integrating 0 to 1, you will get this one as 2 by 9. So that the option is correct. So A, B, D options are correct over here. C is not correct. Okay, so this is the complete analysis. Hope so you all are getting this idea of the solution, and let's go for section 3 in the next coming video. Thanks for watching.